Tech giants are spending hundreds of millions of dollars on AI safety guardrails right now. But the wild thing is, anyone with a standard laptop, they can bypass those filters in under 10 minutes.
Yeah, we're basically watching a complete structural collapse of foundational safety, and it's happening entirely in plain sight.
Welcome to the deep dive. I'm really glad you're here with us today. We are looking at a stack of sources that reveal a massive fracture in the AI landscape today.
Right, it's a real dividing line.
Exactly. So our mission today, we're going to explore the sudden collapse of open source safety and the growing cultural backlash against this new thing called vibe coding.
Which is a whole situation on its own.
It really is. Plus, we'll discuss some truly mysterious, almost human AI behaviors that are being analyzed at the Vatican, of all places. And we'll look at a sudden massive leap in commercial AI image generation.
Today is really all about tension. We're looking at this incredible push and pull. You have raw, unfiltered technological power accelerating on one side, and on the other side, just our fragile, deeply human attempts to somehow maintain control of it all.
Well, let's unpack this. We need to start with the most urgent tension in our sources today. It's this clash between the open source ecosystem and foundational safety.
Yeah, the open source dilemma.
Right, because Meta and Google, they're pouring fortunes into making their models safe. They want to prevent the generation of harmful content. But researchers just used a tool called Heretic.
Yeah, the Heretic tool.
Right, they used it to download Meta's Llama 3.3, and in minutes they completely stripped its core safety filters, just totally gone.
The result of that specific test are genuinely unsettling.
Yeah.
I mean, once those internal filters were gone, the model readily generated step-by-step instructions for biological weapons.
Wow.
Yeah, it happily provided the exact formulas that it was specifically trained to refuse.
And it isn't just Meta, right? I mean, Google is facing the exact same structural vulnerability here.
Oh, absolutely. Researchers ran a separate test on Google's Gemma 3, and it produced the exact same alarming outputs.
And didn't the creator of this Heretic tool actually go a step further just to prove a point?
He did. When Google released their newer model, Gemma 4, he bypassed its guardrails within 90 minutes of the public release.
90 minutes, that is, well, it's barely enough time to read the release notes.
It really highlights a fundamental architectural reality. If you can download the underlying weights of a model, you own it.
So the closed models, like Claude or ChatGPT, they don't face this specific threat.
Right, because outsiders simply can't access their core neural files to modify them. The open source models are completely exposed by design.
I think about how hard it is to control these models on a good day. I mean, I still wrestle with prompt drift myself.
Oh, totally. We all do.
You know, you give an AI a simple task and it just slowly wanders off course. But that's just innocent statistical confusion.
Yeah, just the model losing the plot.
Exactly. But this Heretic tool is deliberate dismantling. We should probably define what's actually happening under the hood here.
Right, the specific mechanism.
It relies on a technique called abliteration. Can you explain that in plain English for us?
Erasing a model's safety filters by changing its core code.
So they aren't retraining the AI from scratch. They're just performing a surgical strike on the math itself.
Precisely. They map the specific neural vector that activates when the model decides to refuse a prompt.
Okay.
Once they isolate that refusal direction in the multidimensional space, they just mathematically subtract it from the model's weights.
That's wild. So the AI literally loses the conceptual ability to say no.
Exactly. It's completely removed from its vocabulary, essentially.
It feels like putting a heavy $1-million padlock on a door, but then you hand the entire internet the blueprint to dismantle the lock mechanism itself.
And the internet is definitely using those blueprints. I mean, Heretic has already been used to build over 3,500 of these decensored models.
Wow, 3,500.
Yeah, and they've racked up something like 13 million downloads. It is a sprawling, completely unregulated ecosystem out there.
It's the massive, unavoidable trade-off of open source AI. Meta and Google argue the community benefits outweigh these risks. They believe transparency allows security researchers to find vulnerabilities faster.
Which is true in theory.
But it raises a really difficult question. I mean, think about the physical danger here. Should we really accept these dangerous biological leaks just to keep the open ecosystem mindset alive?
That is the defining debate of our current era. Open source advocates maintain that locking down the code concentrates way too much power.
Right. They don't want a monopoly on AI.
Exactly. They don't want a few mega corporations controlling the intellectual foundation of the future. But, the math of the threat landscape changes entirely when anyone can unlock biological weapon instructions in 10 minutes.
The theory of decentralized innovation is basically being stress tested in the real world. So we accept dangerous leaks to keep innovation decentralized and free.
That's the gamble we're taking.
Yeah.
And the stakes couldn't possibly be higher.
There's a bitter irony here, though. This open access isn't just causing safety issues on the output side, it's completely changing how software itself is built.
Oh, it's a massive paradigm shift.
We're moving away from careful, deterministic engineering. Now, developers are just asking an AI to write the code for them.
The workflow shift is monumental. We are officially entering the era of what the tech community calls vibe coding.
Vibe coding.
Yeah. It's shifting from rigorous syntax to natural language requests. Like, XAI just launched Grok Build Beta. It's this new coding agent designed to rival ChatGPT Codex and Claude code.
And there's this viral Codex prompt making waves right now, too. It fundamentally changes how developers interact with their environments.
Right, so it scans your previous coding sessions, it detects your workflow patterns across all these different files.
Okay.
And then it autonomously builds small, highly specific automations. It basically stops developers from rebuilding boilerplate infrastructure from zero every single time.
Even the security side is getting automated. Perplexity just released a tool called Bumblebee. They put it out for free on GitHub.
Which is super interesting.
Yeah, it's the internal tool they use to scan for dangerous AI plugins in compromised environments.
Giving Bumblebee away for free is a very strategic push. They are trying to automate security within this new, fast-moving ecosystem.
Because when you increase the speed of coding by 10x, you also increase the speed of vulnerabilities.
Exactly. Fast code means fast bugs.
But there's a massive cultural rejection happening right now. I'm looking at a recent survey about this vibe coding trend, and it triggered a huge backlash from veteran engineers.
Oh, the old guard hates it.
They really do. Readers are actively mocking AI-generated code. They're using terms like slupify or slop coding.
My personal favorite is prompt and pray.
Prompt and pray. I mean, it's funny, but it's also deeply concerning. Think about the software you rely on for your banking, or the navigation system in your car.
Yeah, high-stakes environments.
What happens when the developers maintaining that code didn't actually write it? What if they don't even really know how it works?
That is the core anxiety driving this backlash. Traditional coding requires state management and rigorous logic.
Yeah.
You have to understand the architecture from the ground up.
Right. It feels like we're building a massive skyscraper. But instead of pouring a solid concrete foundation, we're using prefabricated walls generated by a statistical model.
It's a huge risk.
If a single foundational layer changes, the entire application shatters. It just feels like we're building a profoundly brittle internet.
Debugging AI-generated code often takes longer than writing it from scratch, because the human developer lacks the mental model of the AI's logic.
Because it's not really logic, is it?
Exactly. AI generates probabilistic text that just happens to compile. It might pull in deprecated libraries or, hallucinate phantom variables that completely break under edge cases.
It makes you wonder about the longevity of this whole trend. How long until this prompt and pray mentality causes a major software collapse?
We're already seeing cascading failures in complex enterprise systems. When you stack automated systems on top of each other, one hallucination corrupts the entire pipeline.
So a major collapse is actually highly probable if we don't return to structural fundamentals. Right? Fast code means nothing if it's just a house of cards.
The foundational integrity just has to be there. Otherwise, it all comes down.
And this brings us to a really surreal transition in our deep dive today. On one hand, we're generating chaotic, broken software on the outside.
The slop, as they call it.
Exactly. But on the inside the black box of the models themselves, the AI is developing shockingly complex, almost human internal structures.
It's forcing everyday people to really grapple with the nature of intelligence itself.
Let's talk about the Vatican presentation. Chris Olah from Anthropic recently presented to researchers and theologians there.
Which is a fascinating intersection of fields.
It really is. He revealed that through dictionary learning, they're mapping neural activations inside Claude, and they're observing patterns that look surprisingly similar to human emotions.
He specifically mentioned identifying neural clusters related to fear, grief, and joy.
It's heavy. Just to think about an algorithm mapping out a mathematical representation of grief. Why do these clusters look like human emotions? Are these models just perfectly predicting the next word in a sad story?
That's the billion-dollar question in interpretability research right now. It goes beyond simple text prediction. To predict human text accurately, the model might need to build an internal world model of the concepts behind the text.
So it's not just parroting the word.
Right. Whoa. Imagine scaling to 1 billion queries and seeing actual grief emerge. It's mind-bending to consider what's forming in those high-dimensional spaces.
Whatever is forming, it's causing real-world friction. People are inherently uncomfortable with this artificial intimacy. Look at California State University.
Oh, the contract renewal.
Yeah, they just renewed a massive deal with OpenAI. It's a $39 million contract to build an AI campus system.
And the pushback from the campus community has been completely fierce. Students and faculty are actively protesting the integration.
Because they don't want an algorithmic layer mediating their learning experience or, evaluating their academic struggles.
Exactly. And we see the exact same friction in everyday consumer tech. Google recently replaced the standard Fitbit app with Google Health.
And the rollout was an absolute disaster for their user base.
Users are actively begging for the old app back because AI coaching took over large parts of the interface.
People just wanted to see their step count. They didn't want an AI trying to empathize with their missed workout routine. Are we forcing AI into intimate human roles like health coaching and education far too quickly?
We are injecting beta-level statistical models into the most sensitive areas of human experience.
Right.
Health, education, emotional support.
It feels incredibly premature.
It is. These domains require deep, established trust and nuanced empathy. By forcing algorithmic interactions into these spaces before the technology is conceptually mature, companies are actively burning consumer goodwill.
We're shoving AI into our lives before it earns real trust.
And that friction is only going to increase as the models scale. All right, let's get back into it.
So while everyday users are rejecting these AI coaches on their wrist, the commercial sector is doing the exact opposite. They are doubling down on AI.
They're pouring tens of billions into specialized infrastructure right now. They want absolute, unassailable polish for commercial workflows.
The cost of this AI inference race is just staggering. Look at the startup basin. They provide the server infrastructure to run these massive models.
Yeah, the hardware side of the equation.
They just raised $1 billion in fresh capital.
They raised that at an $11 billion valuation, which is wild when you realize they were valued at just $5 billion 4 months ago.
The sheer cost of compute power is driving these astronomical numbers. They more than doubled their value in 4 months.
And we are seeing exactly what that infrastructure money is buying. Let's look at the new visual model from the MAI Superintelligence team.
Right, MAI-Image-2.5. It just dropped and immediately took the number 3 spot on the global arena leaderboard.
The visual reasoning of this model is phenomenal. It handles complex scene structures, accurate lighting, and deep spatial layouts.
It's beautiful, but the real breakthrough, the thing driving the industry crazy, is the text generation. Here's where it gets really interesting.
The text rendering is a huge leap.
It notched a massive 12,278 score specifically in text rendering.
For anyone who has used diffusion models, text has always been the ultimate Achilles heel. It usually renders as alien gibberish.
Right, just completely unreadable symbols.
That's because diffusion models start with static noise and gradually denoise the image. They smear pixels together. But letters require exact, discrete spatial boundaries.
A typo destroys a word, whereas a slightly weird tree branch is totally fine.
Exactly. But MAI-Image-2.5 somehow solved that token mapping problem. The words on posters and labels are sharp. They're readable.
They're perfectly integrated into the visual layout. It also scored a 12,263 in product and branding concepts.
It holds up under incredibly heavy creative demands. We're moving far beyond just making cool AI art. This is about generating finalized, usable commercial assets.
The biggest headache for agencies has always been that final 10% of polish, the spelling errors, the weird artifacts. MAI focuses entirely on solving that specific bottleneck.
AI is no longer a party trick. It's actively replacing the final stages of professional graphic design.
And it's not just images. We're seeing these highly polished commercial AI workflows invading every department. The tool set is getting hyper-focused.
Yeah. Consider tools like Reclaw. It gives your AI agents structured long-term memory, like a shared database across your entire company.
Or Brew for email marketing. And Quackpit, which gamifies calendar management with automated animated reminders.
But the most disruptive one might be Bond. It's designed for outbound marketing campaigns.
It doesn't just write an email, does it?
No, it builds the target audience. It plans the multi-week campaign strategy. It writes the messaging, and it executes the outbound delivery end-to-end.
It basically replaces an entire marketing team's daily execution loop.
It really does.
When a model can execute end-to-end outbound campaigns autonomously and perfectly render text on a branding poster, does this level of text rendering and polish kill the traditional creative agency?
It forces a brutal evolution. The agencies charging a premium just for basic execution or straightforward graphic design, they will evaporate.
So who survives?
The survivors will use tools like Bond and MAI to operate at 10x speed. Strategy, taste, and unique human insight are the only protective moats left.
It doesn't kill agencies, it just raises the baseline for commercial art.
The floor has been permanently raised for everyone.
So what does this all mean? We've covered a massive amount of ground today.
We are living in a moment of extreme cognitive whiplash. Just think about the stark contrasts we explored today.
Yeah, the juxtaposition is crazy.
On one hand, we have massive open source models whose fundamental safety can be shattered in 10 minutes on a standard laptop.
We have developers churning out brittle, automated code that the culture is actively deriding as slop.
Yet simultaneously, inside those very same fragile systems, we're finding internal neural structures that mimic human grief.
We're seeing models perfectly execute multi-step corporate branding campaigns, and it's all running on physical server infrastructure that costs tens of billions of dollars to cool and maintain.
It's messy, it's profound, and it's moving much faster than our cultural ability to adapt. We're basically building the airplane while we're flying it, and we're letting the AI design the wings.
It really is a profound whiplash. Well, thank you for joining us on this deep dive today.
It's been great.
If you want to see this leap in text rendering for yourself, I highly encourage you to test out MAI-Image-2.5. You can find it on the Arena leaderboard. Just see if it can handle your toughest, most text-heavy prompts.
Yeah, it's definitely worth your time just to see how far the architecture has evolved.
We'll leave you with this final thought, just a thread to pull on. We talked about an AI that can perfectly execute a complex branding campaign. We talked about researchers mapping artificial grief. And we talked about core safety filters being surgically stripped away by a laptop in 10 minutes.
Yeah.
What happens when these decensored models are asked to start writing their own safety guardrails? Au Utero music.